Hello, students. This primer is on shallow versus deep copying of Python lists. Now, when we copy one list to another, we kind of have the human expectation that we're creating a separate list. So for example, if we have list A is 1, 2, 3, and we want to create a new list B and just simply assign it the contents of A, we would assume then that we have two completely separate lists here, and that any alterations to A, of course, would not be evident in B, and any alterations in B would not be evident in A. However, this is wrong. When we do this particular assignment statement, we're doing what's called a shallow copy. And what is a shallow copy? Well, that's simply, we are still referring to the same place in memory. Here is a good old Python list with some values. And if we assign the name A to it, the variable name A, in Python, everything is really object and reference driven, very much like C++ pointers. And although we don't have to do pointer manipulation in Python, they're still very much evident. So when we do this assignment of B equals A, what we're really doing is just giving an alias to A. So A still points to this, and we're giving a new alias B, and guess what? It still points to the original list. So if we alter it and put a 500 in here, thinking that we're just going to modify list B, sure enough, list A is altered. Now let me demonstrate some code that shows this. I'm going to pull up my PyCharm here, and here's a couple of lists, right? Here's list 1 of just a bunch of odd numbers, 5 odd numbers. Here I create list 2 as a quote copy. I'm hoping and praying it's just a copy. And then look what I do here. I use append. That's a method that we learned in basic Python to just simply add the element 11 to list 1. And then I want to get another append operation on list 2. We're going to append 13 to that. And then check out this behavior. When I print list 1, it's going to actually output this data here, and look at that. It includes both 11 and 13. Now 11 we had just appended to list 1, and 13 we had just appended to list 2, and yet it's evident in both. Let me get this up and running real quick, and you'll see here in the output that matches just the comments next to those print statements. Same thing here if I print list 2. It is going to print out this exact same thing, and here it is. So we very much have the situation where we're still dealing with just one entity, one object that's resident in memory, and we just have two different pointers to it, two different names to it, two different aliases to reference this single slice of memory. So that is a problem. And again, this is called a shallow copy. And it really comes into play when you expect that the lists are completely independent, and they're not. So there's one solution for this. First, I want to talk about a couple more scenarios. Here's another bit of code, and of course, I'll post all of this code onto our LMS for us, onto Canvas. Now here, I have a list A that has 3 elements. It's got a 1, a 2, and then it has an internal list in and of itself with the values 5 and 10. All right, here we are going to create, using list slicing, we're going to use this syntax here to try and have a unique copy made. Now, normally this list slicing like this will work provided that there's no underlying, I'll say, more complex or level 2 data structures. It'll work if you've just got a bunch of integers in there with no other types of objects, or say a bunch of strings or a bunch of floats and nothing else, no other types. It faults anytime you have anything more complex than a native data type. So if you have a list within a list, this is going to fault. If you have an object within a list, it's going to fault, etc. And then here's kind of what is going on with it. So here, we hope to do this member-wise assignment, and we hope that it works. And then here in this code, I am just altering, oops, didn't want to do that. I am just altering some of the elements here in list B. I want to zero out everything in list A and zero it out for list B. So now when I run this, and let's get this up and running, we can see here that list B properly prints out here. It prints out all zeros just like we intended. So we think, oh, good, good, good. We're golden, right? The problem here is with list A. Look at the output to that. It actually output 0, 0 for the list within the list, or the complex object, or kind of the level 2 object. We'll kind of refer, use names like that to describe, this particular element. It actually changed it from 510 to 0, 0. So this is just a demonstration that normally this member-wise assignment using slicing works. However, it won't work if you have a more complex object that's an element of your list. So there is a way around this though, and that is to use deep copy. Now here's some code here. I'm taking this exact same code that we saw and that faults, and I'm going to now apply the deep copy methodology. So first of all, of course, we import copy because we're going to call one of those methods. And this will do a deep copy. And a deep copy is where it's not just the surface layer that's being copied over, and then we get some aberrant behavior. A deep copy is going to go element by element and make a pure, genuine copy. And if it's a list within a list, it's going to do a pure, genuine, member-wise assignment of that list within a list. So here, we are creating, we've got the same list A with the embedded list. Here we're going to do a deep copy of A. Here I'm going to keep doing the manipulation of list B to zero everything out. And then let's get this up and running, and we'll see that of course this matches the code that I have in the comments. Is that when we print A this time, it actually outputs the original intended values here. And then when we print out B, well, look at that. It's properly zeroed out because we did manual reassignments of all of those elements, including the embedded list within a list. So this is showing that this deep copy works. And one of the takeaways then for this little primer is to go ahead and use deep copy whenever you have, at a minimum, whenever you have some more complex embedded object. But in general, it's a good idea to just use it all the time. If you're gonna copy one list to another, just go ahead and go use deep copy, and you won't even have to worry too much about it. Now back to our original problem that we had. I'm going to now apply the deep copy principle to that original problem where we first had list 1. Let me get this up and running first, and I'm on 3. List 1 is 13579. List 2 now does a deep copy of list 1. So list 2 is now 13579. I'm going to append 11 to list 1, and I'm going to append 13 to list 2. And let's pray that the output then is unique. And sure enough, when we run it here, now let me expand the output, we do see that the list 1 output is different from the list 2 output. So that's showing that this deep copy works. So hope this helps as a good refresher and explanation of what deep copy is versus shallow copy. And in general, again, if you have any complex data structure as part of your list, or if we're going to do something even more complex like more advanced data structures, use deep copy. Okay, thanks.